What is up, everyone? For those who don't know me yet, my name is Matt and we're here talking about gameplay animation. And today I wanted to tackle something super important in the field, and these are animation graphs. So we'll be using the Unreal Engine 4, we'll be having an overview of the animation blueprints. I'll be explaining what is a state machine, and we'll be creating our very own altogether that will allow you to move your character around. I think we're ready. Let's start. Alright, so first thing first, let's create a new project. So just click on Games over here, click on Next, select the third person over there. Next again. Everything by default, you just want to leave all this. Select the folder and give it a name. I'm gonna name mine Blueprints Intro. Create project, and then we're gonna land in the third person demo that Unreal provides for us, which is pretty simple, but contains the all the basics and that we're gonna need to for this video. And generally speaking, for you to understand, what is a blueprint and how is everything working under the hood. So let's click on play here. You'll see that the camera is automatically gonna change and be snapped behind your character. If you click once again in the game window, then you will have the control over the camera using the mouse. So you have a bunch of options here. The mouse is, so the camera is providing the forward direction for your character. So let's just say you're pointing to the back of the character. If I press W, which is move forward, you have the WSD keys. If I press on W, then the character is gonna turn around and move towards where the camera is pointing at. So this is one of your options. If your character is running forward, moving forward, and then you're moving your mouse, you're just driving the character orientation. The second option you have is just to use the keyboard keys. So if I'm facing forward and I press S, then I'm gonna work towards the camera, backwards, right? And then obviously A and D are for the sides. And when you combine, say, forward and right, then you will go at 45 degrees at an angle. What you can do as well is what the demo provides is a jump. So if you press space, the character is just gonna jump, and then when he breaches the surface once again, the ground, then you have a land animation. So what is actually happening is that we're constantly checking if the character is in the air. So if you go up those stairs here and just keep moving forward, then when the character detects that there's no ground anymore, he will actually jump. Just for you to understand how it works. Yeah, and that would be it. So just press escape to stop the simulation. And what we will do right now is just to see how they built that animation graph that is driving that character. So over here in your content browser, just go back to content, double click on mannequin, animations, and then you will have over there, you will see, so these green elements here are all the animations that the project is using. Over there you have a blend space that we'll be covering in another video. What we want to see today is this, the third person anim BP for blueprint. So go ahead and double click on this. So this is our main window. So this is the animation blueprint. So the biggest window you have here is for the graphs itself. So you have both the animation graphs and even graph over there. I'll explain what they do and what the difference between them two in a minute. Over there on the left, you have the preview of the current pose of your character. Down on the bottom, so below that, you have what is called the My Blueprint. So it's just like the tooltip says, all the elements that belong to this exact blueprint, so some kind of a browser for that specific blueprint. And you can already notice here you have a list of variables that are already defined in that specific animation blueprint. And we are going to be using these, or at least the speed one in that video. So just for you to have in mind, this is where they're defined. And I'll explain in a minute how they're updated and how does the animation graph uses them. Underneath the viewport, the main window, the graph window, you have a compiler window here. So this is basically for all the warnings and potential compilation errors. On the right side, you have a couple of windows. So the details one is just basically the properties of the current. So it's contextual. You know, if you click on the node, you will have the details or the properties of that said node. And then below that, you have the asset browser. So you might remember we had all those animations in green here, as well as the blend space. And then you have as well some properties over there for the animation preview. So let's have a quick look at the event graph for a moment. So just click on the tab up there, event graph. I don't want to go too much into details. What I just would like you to understand is this is where we process and update variables based on the data that is provided to us by the character, basically. Using a quite simple system of nodes over there. A node is most of the time, so in this you can see that F here, this is just a function. So this is a visual representation of a function that is written somewhere in code, and you just create that node and say, at that specific point, please give me, for example, in our case here, the movement component of the character, and then based on that component, which is an array of properties based on the current set of the character, you just ask, can you tell me if it's falling yes or no? And then, based on the result of that function in code, we in turn update our own variable. So that's for the air, and so is in air, sorry. And then we're just doing a very similar operation, or just in the essence, for to get the speed of our character. And these variable in turns are gonna be something we're gonna be able to operate on in the animation graph. So let's switch back to it, where this is where the true magic happens. So this is where you're gonna handle the visual representation of your character. What happens here is that view is pretty simple. See, you have a default, which is a state machine, and then you have the output pose anim graph. So if you hover on it, it just says wire the final animation pose for this graph into this node. So what happens in essence in an animation graph is that something, and we'll see what in a minute, processes at each frame the pose in which the character is supposed to be. A pose, I mean, you know, an animation is just an array of pose. So at each frame, when you have a walking loop, for example, at each frame, your character has a different pose, right? And it makes, over the time, an animation. What happens over here is that if you have only one animation being played at that moment, then it's the direct translation one-to-one from that animation. But then in video games, you know, it might be more complex. You can be transitioning from an animation A to B. You can have a blend between two animations, which would be, for example, using layers. So I am reloading while running. So you have a more complex processing to do, because you have to understand how the pose of the running animation looks, as well as the one from reloading. And what happens is that the graph processes all this, and then after all the necessary operations, just send it to the output pose, which would be what we see on the screen while you're playing, what is also displayed here in that preview window. We'll pause the video here, and in the next one we'll be covering what is a state machine, and we'll be creating our own to be able to control our character. See you in a minute.